Hello YouTube, this is going to be a video series on the Linux kernel, and we're going to talk about what the Linux kernel is, and we eventually will get into Linux kernel programming. The Linux kernel is really a way to have a centralized interface between the user and the machine. So basically it allows the user to talk to the hardware of the computer in a more direct and efficient way, as opposed to the user having to know assembly language to manage all the many complexities of talking to specific hardwares attached to your machine. A graphical organization of the kernel is as follows. Essentially, you have your hardware, which is your machine, and it can have a number of devices attached to the computer, like maybe you have a microcontroller, or you have a wire attached to a peripheral device like a keyboard. All those hardware components are managed by the kernel, and in turn you have shell programs or user applications that talk to the kernel and make requests to utilize either the monitor, save information to the hard drive, or get input from the keyboard. So the relationship between the kernel and the user is like this, basically. So you have the user space or the shell application making requests from the kernel, like print a message to the screen or get information from the keyboard. It makes those requests to the kernel, and in turn the kernel goes ahead and satisfies those requests by talking to the hardware. Inside the kernel there are process schedulers, memory managers, and input and output schedulers. Process schedulers allow the kernel to give equal time to different processes. Processes are programs that are actively running in memory. And memory managers allow for a way to manage, share, and allocate memory space for different applications, so they can all share and play nice with each other. Input and output schedulers allow for the use of the keyboard and other writing operations. Also, the kernel is composed of IPCs, and IPCs are inter-process communications, and this comes into play specifically with multi-threading, allowing for semaphores. And if you don't understand some of these concepts, it's alright. In due time you will. It's also for locking. So if you have multiple threads running, you can have synchronization between them. And then also the kernel is composed of, it has ability to interface with network services, so your NIC cards can work, and so you can have internet access. Also, there's the file system. The kernel, Linux kernel, the Linux system has a number of different types of file formats that it can support, and all of them all have different variations. But all in all, the Linux kernel has also a virtual file system, and the virtual file system allows the kernel to be able to talk to different types of supported file systems inside of Linux and talk to them in a uniform manner. And so the virtual file system inside of the Linux kernel allows for a level of abstraction, so it doesn't have to deal with this number of many individualized complexities that result from having so many different types of supported file systems inside Linux. So the virtual file system is very important. And then also this file system talks to the device driver, and the device driver in turn talks to the hardware. And so this overall is the components of the kernel. Earlier I talked that the user space and the shell programs talk to the kernel by making requests. But I should mention now that the kernel runs in a very privileged environment, in that it can access any aspect of the computer at any time, and access the full range of memory, and talk to all the hardwares attached to your computer. Whereas in the user space, it has very limited access to a number of resources, including memory and including hardware devices like the monitor, keyboard. So all of its requests have to be made via the kernel. And of course, from this privileged mode, the kernel talks to the hardware and satisfies the request of the user or shell applications. But what you cannot do is, from the user space, directly talk to the hardware. That is a no-no. A way to get around that, like I explained earlier, is for the user to talk to the kernel by making a request, and those requests are called system calls. And in turn, the kernel makes its form of a call to hardware via interrupts. So the hardware interrupts the kernel, tells it has data for it, or the kernel talks to the hardware, writing information to the hardware. Alright, to get a recent copy or the latest copy of the Linux kernel source, you can go to kernel.org and you can get a copy. I haven't spelled that. But on your system, if you want to find out your current running version of the kernel, you can type uname with the flag R for release version, and that will give you your current Linux kernel version. There's a special numbering syntax they use, and the first number is called the major number, and the second number is called your minor number. And the minor number, if it's even, that means it's stable, versus if it's odd, it means it's more experimental, it's in a developmental stage. And the last number is the revision number. After you get a copy of the current source, the current kernel source, you can unzip it inside of your user USR directly under source. Well, that's going to do for this tutorial. Join me next time and we'll go more into detail about the Linux kernel. As always, please subscribe. Depending on the feedback, depends on how much more of this series I will produce. Thank you.